Imagine you're sweltering in 40 degrees Celsius heat, parched for a drop of relief. But then, in the blink of an eye, rain pours down, cool and refreshing on your command. It sounds like wizardry, or Hollywood CGI, but what if I told you there are real scientists, armed with planes, rockets, and radio antennas, seriously trying to bend clouds, storms, and sunshine to our will? Today, we're gonna get into the boldest, craziest, most controversial world of weather control. By the end, you'll know which parts are proven, which are pipe dreams, and what it might mean for our planet and your backyard barbecue. Long before radar and rockets, people across the globe turned to ritual, myth, and dance when the rains failed. In China's Yellow River Basin, over 4,000 years ago, oracle bones record ceremonies where shamans paraded through rice paddies with incense and drums, calling on the dragon god to weep. On the high plains of North America, tribal rainmakers donned eagle feathers and danced for days, their chants echoing off the buttes. West Africa's rain rituals blended drumming, masks, and secret chants said to coax clouds from the heavens. Of course, these were acts of faith, not chemistry, but the human impulse was the same. We've always craved influence over our environment. Fast forward to the 1940s, when two curious scientists at General Electric in Schenectady, New York, Vincent Schaefer and Bernard Vonnegut, stumbled into weather modification quite by accident. Schaefer, tinkering with dry ice in a cloud chamber, dropped a pellet into supercooled water vapor and watched it crystallize instantly. He realized that if you could seed clouds with freezing nuclei, you might induce rain or snow on demand. Vonnegut then discovered that silver iodide, long used in photographic chemistry, was even more effective. Its crystal structure mimicked ice, creating a scaffold for water molecules to freeze upon. In December 1946, GE pilots scattered dry ice pellets over a towering cumulus cloud, and within minutes, it showered below. It was an electrifying moment. Humans had, for the first time, performed a small miracle in the sky. But miracles come with consequences. In 1947, Project Cirrus aimed to steer Hurricane King away from Florida by seeding its outer bands. Instead, the storm pivoted towards Savannah, Georgia, causing property damage. The controversy was so intense that GE quietly handed all data to the US military for classification, and folks still debate whether that one seeding actually nudged the hurricane's path. By the 1960s, the Cold War supercharged weather warfare research. Operation Popeye saw clouds darken over the Ho Chi Minh Trail in Vietnam, with the goal of forcing supply delays. Monsoons extended by weeks at the cost of diplomatic outcry, and ultimately, the 1977 Environmental Modification Convention banning hostile weather as a weapon. Human ambition had outpaced international law, and scientists realized that tampering with the atmosphere could trigger far-flung side effects: floods, droughts, and cross-border blame games. Today's cloud seeding is a far cry from tossing dry ice by hand. In China, the People's Liberation Army runs an armada of nearly 1,000 cloud seeding aircraft and over 2,000 ground generators to blanket an area twice the size of France in silver iodide annually. Their goal? Protect the Beijing Olympics, boost wheat yields, even ensure water for megacities. Reports claim up to 20% more rain in seeded regions, but critics argue measurement is spotty, and natural variability plays a giant role. Here's how it works. You introduce tiny hygroscopic or ice-nucleating particles into supercooled clouds. These particles, silver iodide, potassium chloride, or even table salt, serve as condensation nuclei. Water vapor, eager to solidify, clings to these nuclei, forming droplets or ice crystals heavy enough to fall. The tricky part is delivery. Ground-based generators burn iodide salts and propane torches, lofting particles updraft by updraft. Airborne platforms, from modified crop duster planes to high-altitude drones, spray a precisely metered plume of particles into target cloud layers. Rocket-launched flares can reach stratospheric clouds in remote regions, though at a steep cost per mission. One of the most ambitious civilian projects is in the Colorado River Basin, where snowpack levels are essential for water supply. By seeding winter storms before they hit the Rockies, scientists hope to increase snow depth and thus spring melt runoff by 10 to 15%. That might translate to tens of millions of extra gallons for irrigation and drinking water, potentially saving local economies billions. But success depends on temperature profiles, moisture content, and even wind shear. Seed the wrong cloud at the wrong time, and you get nothing. Firefighters have also gotten in on the act. Ahead of major wildfire seasons, some agencies seed storm cells to drop pre-fire rains, creating natural fire breaks. In Australia's bushfire-prone regions, small fleets of helicopters spray iodide into approaching storms, sometimes delaying dangerous wind shifts. The results are mixed. A few sites report extended periods of drizzle, but others see no significant change. The bottom line: you can tweak a brewing storm, but you can't compose symphonies with it. Next up, the eerie glowing arc of conspiracy, HAARP, the High-Frequency Active Auroral Research Program in remote Alaska. Built in the 1990s, HAARP's 3.6 modules of HF radio transmitters can zap the ionosphere, creating tiny pockets of heated plasma and artificial aurora. The official line: communications research, subpolar physics, and the study of natural phenomena like northern lights. Yet to some, HAARP is the ultimate weather weapon. Headlines have claimed it triggered earthquakes, tsunamis, droughts, even mind control. Let's bust a few myths. The energy HAARP beams upward is minuscule compared to what the sun delivers every second. A single thunderstorm packs around 214 watts. HAARP's total would barely budge that. You can create minor ionospheric ripples but steer a hurricane? Not on this grid's power bill. Real cutting-edge research explores charging clouds, electrically pulse high-voltage towers at ground level to alter the balance of positive and negative ions. In theory, you could suppress lightning or nudge droplet formation, but practical tests are in early lab stages, and scaling up would require millions of dollars and megawatts of power. So unless you've got Elon Musk's bank account, HAARP-style weather dominion stays in the realm of sci-fi conspiracy. Let's dream even bigger. Geoengineering, the intentional large-scale manipulation of Earth's environment to counteract climate change. Two main camps divide the field: solar radiation management, SRM, and carbon dioxide removal, CDR. Let's begin with SRM, the planetary sunshade. After Mount Pinatubo erupted in 1991, its sulfur dioxide plume formed stratospheric sulfate aerosols that reflected sunlight, cooling the planet by about 0.5 degrees Celsius for 2 years. SRM tries to replicate that. Stratospheric aerosol injection, loft sulfur molecules via balloons, aircraft, or even naval guns. A small fleet could inject millions of tons of sulfur annually, dialing global temperature down by fractions of a degree. Marine cloud, brightening. Specialized ships spray ultrafine sea salt into marine stratocumulus clouds, whitening them to reflect more sunlight. Early experiments off Australia's coast showed a small cooling effect, just enough to spark excitement and alarm. The catch: SRM doesn't remove CO2 oceans, keep acidifying. Ecosystems keep unraveling, and regional side effects loom. Rain patterns could shift, monsoons weaken, and nations downwind might endure droughts while others benefit. Now let's come to CDR, vacuuming CO2 from the air. Direct air capture, said DAC. Gigantic fans pull in ambient air. Chemical filters trap CO2, later compressed and stored underground in old oil fields or mineralized into solid rock. Companies like Climeworks are building pilot plants in Iceland, sending thousands of tons of CO2 into basalt formations. Ocean fertilization, sprinkling iron into nutrient-starved ocean gyres to spur phytoplankton blooms that sequester carbon. Field trials off Canada and Chile saw mixed results and raised red flags about algal toxins and oxygen depletion, storm busters and hurricane hamsters. Some engineers propose bubble curtains, long lines of submarine jets under a hurricane's path, pumping deep, cold water upward to chill the storm's heat engine. Some also imagine fleets of solar reflective buoys bobbing in the Gulf of Mexico to shave sea surface temps by a degree or two. Computer models suggest potential 10-20% reductions in peak wind speeds, but real-world tests remain theoretical and massively expensive. Imagine a startup called Atmosco begin providing their weather plans in upcoming years. Basic breeze, moderate wind for air pollution control, premium precip, guaranteed 5 mm of localized rain, ultimate sunshine, clear skies for up to 72 hours. Farmers, event planners, and even theme parks might flock to subscribe, so long as the price per cubic meter of water doesn't break the bank. But with patents, private satellites, and corporate lobbying, we risk a future where only the wealthiest can call in the clouds. So putting everything on one plate as climate change ramps up, pressure to engineer our planet will only grow. Will we have the power to enjoy the weather of our liking? Or will stumble into unintended consequences? And now over to you. If you could command the weather for a day, what's your first move?